Okay, so during that activity, you should have started to see compound inequalities. And those are inequalities instead of like one limitation, you have two limitations of some sort. So on the bell work, it talked about baking. So who's ever like baked or cooked before, like using a recipe? Okay, so most recipes don't say like cook it for this much time. It usually says like between 18 or 22 minutes, or boil your water for 9 to 11 minutes. And they do that because they know that some ovens work faster than others. Some stoves, like same thing, work faster than the others, especially if you have like a gas stove. But anyway, what if they just said bake for at least 18 minutes? What do you think would happen? Yeah, someone may bake their cake or whatever for like an hour or 2 hours, and what would happen to that person? Oh, yeah, they would be sad because they'd burn something. So these companies have to use what's called a compound inequality. So a two like edge limit on where you could bake that cake or what that recipe needs to follow. So we're going to talk about compound inequalities because we're going to have two different situations that could happen. Compound, I'm sure you've heard that hopefully in like language arts. Where have you heard compound before in language arts? Yeah, compound sentences or compound words. So like a compound word is like airplane, air and plane put together to make one word. Football. Trying to think. Say it louder. Toothbrush. That's a good one. Toothbrush. Huh? Sandwich. Yes. But like sandwich, I guess, doesn't have sand in it. But yeah, sandbox. Anybody else? Compound word. Backpack. It's a good one. Surfboard. I'm looking at compound words. Moonlight. Notebook. Pickup. Rearrange. No, rearrange wouldn't be. Is re is a prefix, right? Yes. Come on, y'all. You're smart. Yeah. Okay. Sailboat. Anyway, regardless, there's lots of compound words. There's lots of compound inequalities. So you have a choice, option A or option B. Option A, you get to play NBA 2K or whatever game that you like to play after you clean your room and do the dishes. Or option B says you get to play NBA 2K after you clean your room or do the dishes. Is it? Okay, I'm assuming you'd probably choose option B. The reason why is the difference between these two is option A, that and indicates you have to do both things. So A, you have to do both chores. And option B, you only have to choose one to do. So maybe you're just a nice person and are going to do both for your parents. But if not, then option B is fine. Should keep your room clean no matter what. Who has a clean room? Raise your hand. Be honest. Who has a messy room? There's a difference between messy and dirty. Like messy just means you have like clothes everywhere. Dirty means you have like food and like that kind of stuff. Who's messy? Okay. And if you didn't answer, I'm just gonna assume that you're dirty. It's fine. So we're gonna look at two different kinds of compound inequalities. Ones that have and ones that have or. So if we have an and, that means both things have to be true. So if we look at this first one, 2 plus 9 equals 11, and 10 is less than 5 plus 6. So is 2 plus 9 equal to 11? Yes. Yeah, okay. And is 10 less than 5 plus 6? Yes. And since both of those are true, they both have to be true. We're going to go ahead and circle this because both are true. The next one says 4 plus 5 does not equal 9. That's false. But what about 2 plus 3 greater than 0? That's true. So do we circle it?
No.
No, because the word in between says and. So that means both of them have to be true. So we can't circle because one is false. Okay, now I want you to look at the difference here. This one says or. So 0 is greater than 4 minus 6. Is that one true? Yeah, because 4 minus 6 is -2. 0 is greater than -2. Or 3 plus 2 equals 6. No, but can I circle it? Yes, because it's an or. That means only one has to be true. And the last one, 15 minus 20 is greater than 0. That's false. Yeah, -5 is not greater than 0. What about 2.5 plus 3.5 equals 7? No, so they're both false. So we can't circle that. We can't circle that one. Even though it's an or, at least one of them has to be true. So we have two situations. When there's an and, so if there's an and between them, both of those statements have to be true. If there's an or in between them, at least one, but both could be true. It doesn't matter. We just want to look to make sure that at least one of those things is true. So let's look at an example of an inequality. So x is less than 6 and, we have an and, x is greater than 1. So someone give me a number that would work for both of those. Because remember, it's and, it has to work for both. Something that's less than 6 but greater than 1. 2, what else? 4, 3, 5, 5.1, 5.2, 5.3, 5.4, lots of numbers, okay? So if we were to graph this, instead of having one circle, we're gonna have two circles. We're gonna have a circle around 1 and a circle around 6. Am I gonna fill in either of those circles? No, because you'll notice that there's no equal to, there's no line under either of those. There could be, but in this case, there's not. And for me to describe my answer is anywhere in between there. So we're gonna shade everything in between the 1 and the 6. So this is the graphic solution, graphic of this inequality. How many numbers would answer this? Use a math word. Don't say a lot, because it is a lot. How many different answers does this have? Between 1 and, how many numbers are between 1 and 6? Yeah, infinite. Yeah. So we could go back to the game where I say 1.1, 1.01, 1.001, 1.0001, 1.00001. I could get super close to 1. I could get super close to 6, and I could describe every single number in between. So infinite number of numbers. There's an infinite number of numbers between 1 and 2. There's an infinite number of numbers between 1 and 3. It's just, there's some infinites that are bigger. It's a little over your head, but there is even though that's a finite space, there's an infinite amount of numbers in there. I want you to underline or highlight or whatever this right here. 1 is less than x is less than 6. When we have an and, you will 99% of the time see it written like that, with your variable in the middle and then your two like limit numbers on the outside. Instead of actually writing the word and, you will most likely see it written like that. And how that's read is x is greater than 1 and less than 6. That's how you're going to read that. X is greater than 1 and less than 6. Okay, so let's look at an or. So that was and, this is or. X is less than 1. or x is greater than 6. So we've kind of switched direction here. Before we answer this question, I want to graph it. So just draw a little number line. You don't have to draw all the numbers. All we're going to do is draw a 1 and a 6, which are our two numbers that we're dealing with. We're still going to have circles around each of them. X is less than 1 is our first inequality. So if we're less than, we're going to shade to the left. And if we are greater than 6, we want to shade to the right. So I want you to see the difference between an and graph and an or graph. An and graph is graphed between the numbers, an or graph is graphed away from those numbers. Could we have written this or graph like this? So similar to the and, could we have written it like that? So it's saying that I need a number that's less than 1 and greater than 6, the same number. Is that possible? Someone give me a number that's less than 1 and greater than 6 at the same time. Yeah, say it louder. What? That doesn't make sense. You cannot have the same number that's less than 1 and greater than 6. So you cannot write it in this form. You have to have that or in between. We cannot combine them into one inequality. So ands we can, because it's the same number that satisfies both. But in this case, we have to think of different numbers. So a number less than 1 would be like 0. Or we could get a number greater than 6. That would be like 10. So we're either satisfying the first inequality or the second one. And we can't write it like this because it's an or. So let's look at a few or problems. So x equals 2. That's our first situation. So that means we're just going to have a dot above 2. Or x is greater than 5. So if we have a circle around 5, the greater numbers are where? Which way are the greater numbers? You got two options, right or left? Right. What about x is greater than 6 or x is less than 6? What do you think that would look like? X could be greater than 6 or x could be less than 6. Yeah, it'd have two arrows on the side of what? 6, yeah. Do I fill in the circle around 6? Yeah, there's no equal to. So all we're doing is we're shading every single number except for 6. So any number works for this problem except that one number 6. Okay, I'm going to skip seed for just a second. I actually want you to add a problem. And I'll zoom in for you. It says 10 is less than or equal to 2x minus 4, which is less than 16. I want you to notice that x is not by itself, and that's a problem. All the other ones we've looked at so far, the x was by itself here and there, and even on the and problem, x was in the middle by itself. So if it's not by itself, we need to make it by itself. And we can do that by solving it just like we have every inequality and every equation in this class so far. So if we look at that x, it's being multiplied by 2 and subtracted by 4. So we want to do the opposite of those things. So the opposite of minus 4 would be plus 4, but you have to add 4 to all parts of that inequality. So before we just had two sides of the inequality symbol, but because we have two inequality symbols now, you have to add 4 to all 3 pieces of that inequality. So my 10 plus 4 would give me 14, is less than or equal to 2x, which is less than 16 plus 4 is 20. And x still isn't by itself. It's being multiplied by 2. So we want to do the opposite, which would be to divide by 2, but we have to do that to everything. 14 divided by 2 would be 7, is less than or equal to x, which is less than 20 divided by 2 would be 10. So that is what you would end up graphing, okay? We can't graph anything until we get it to that x being by itself, and you just solve that just like you would any other inequality. Okay, so we're not going to graph it, but if you were, it would be a closed circle around 7, an open circle around 10, and shaded in between. Okay, so let's go back up and look at C. I see an issue with C. X is not by itself. Technically, what is that coefficient of X? A -1. So -1 is being multiplied by X. So we want to divide everything by -1. So 1 divided by -1 would be -1. We have our X, and we have 7 divided by -1, which is -7. There's a rule though. What do we do when we multiply or divide by a negative for inequalities? Yeah, we got to flip the signs over. So instead of these less than or equal to's, they're going to change to greater than or equal to's. And that's still the same, just like if it were just one symbol. If it's multiple, you change them both. So we're going to have 2 closed circles, one around -7, and one around -1. And we're going to shade everything in the middle. And that would be it for that one. Okay, we're going to look at 2 more problems together, and I'm going to have you practice some on your own. So these were given the graph. We just have to write the inequality. So just looking at letter A, is that an or an and? It's an or. How do you know? Yeah, we're shaded away from each other. So that's going to be an or. So that means somewhere I'm going to have to write the word or. So let's first look at the left-hand side. So X is going to be, since it's shaded to the left, less than -2. And for the other one, since it's shaded to the right, X is going to be greater than 5. What about the second one? Is that an or an and? It's an and because we're shaded between. So that means my X is going to be in the middle. My lower limit of my inequality is -2, and my upper limit is 5. Notice on the -2, there is a closed circle, so we want a less than equal to. And then for the 5, we just want a less than because it's not filled in. Okay, so I want you to do the try it. I'm actually going to have you go all the way to beat the test just because these problems don't take very, very long. But on the beat the test, do not follow the directions. Just answer the inequality part on the beat the test. You're doing the try it, A, B, and C, number 5, A and B, and then the beat the test questions. It shouldn't take you terribly long. When you're done with those, though, you can go ahead and get started on your homework until we take our break, okay? If you're not paying attention, I'm not answering your question when you get to this question in a little bit. So keep that in mind. So number 6 is talking about test grades in a class. So it says Amaya's test scores in Algebra 1 are 78 and a 91. And she has 1 more test left and wants to earn a B for the course. Okay. And it says a B obviously is somewhere between an 80 and an 89. Does the B include 80? Does the B include 89? Okay, so we want these, right? Less than equal to, less than equal to. And in the middle, we're going to describe her average. Okay. So how do you find an average of scores of some sort? Or how do you find an average of any set of numbers? What do you do to find the average? They're the mean or average. Yeah, Gavin. Right, you add up all the numbers and divide by however many numbers there are. So in this case, she's gonna take 3 tests. She knows she got a 78, plus she knows she got a 91. She does not know what she got on the third one. So we're gonna use a variable. What variable do you wanna use? Sounds good. But we need to divide all of that by how many tests she's gonna take. So she's gonna take how many tests? 3. And that's going to give her average. Now, that is how you're going to set up number 6. Number 7 is asking, what's the minimum score she can get on that third test? And to be able to find that out, you're going to solve this, get X by itself in the middle. And I'm not going to show that part, but this is how you should set up number 6, the inequality. And then 7, you're actually finding out what her lowest test score could be to keep a B in the class. Okay. Need help with that second part, let me know, but that would be for the first part.